Okay, so we're going to be building a library called Pledge, which is going to be our promise library. And frankly, it's probably better named than Bluebird, which is another promise library that we use, although ES6 has some support for promises, but not as quite as much as what Bluebird has. But we've been okay so far, I think, using native promises. So if we sort of think about the async operation and how this ends up working, if we end up running this query, we'll find out whether or not, this was our node Postgres. In fact, if this was within an Express application, we've got our callback, and if there's an error, we end up, and again, you always hear me say this, although he could have done this here with an else as well. And I try to do the same thing that is being done in the slide of just saying, hey, look, the only reason you end up returning from a callback is if you just want to get out of there. So you're basically going to call next with the error, as opposed to sending back the data. You could also, do things this way, which is, slightly different if you had a promise library, which gives you the same sort of thing. The big difference is that, you have a then here. And in essence, what you're doing is you're passing in, you're defining two functions for your then. We haven't done this too often, but one of the things that the promise specification says is that when you hit a then, if you have two functions there, the first one will be for success. The second one will be for failure. Anyone know what the third one's for? Nothing. I have no clue. I don't think it really pays any attention to the third function. The only thing that matters is success and failure. So here in this case, even though you just next is a function, and next will get called with whatever the error was of this query. What's actually happening here, really under the covers, is this is the equivalent of having this second function be a next, right? Instead of actually, putting a next here, we could actually catch that error and do something with it, send out a page with a different status. Really ends up getting you the same results. The thing that's nice about promises is that you have this whole idea of portability, meaning that if you're sitting with this promise, you could call then on it, but you also have the ability to export it. So this is the same thing that we saw before. Really, again, the reason why you're doing it, why you're able to do this, is that you're able to separate out the callback function from the asynchronous part of it, right? Because in essence, you could basically take this thing as a promise, and when you have it as a promise, you could then call then on it and deal with it at that point. And in essence, this gives you the ability to export the promise. If you remember, it turns out we didn't really need it. When we had that method where we were connecting to a database and we said, hey, look, if the promise already exists, just send back the promise. That was basically a portable promise that we were doing. And so one of the things you could end up doing is that you could end up collecting promises. So here we've got this promise for different days. And we could end up collecting all these promises. We've got this plain old for loop, which is simultaneous. And then we could end up calling promise.all, and we can end up, theoretically rendering, all these days. The thing that really makes things interesting is this idea of chaining, right? So one of the things that we've seen is that we could get a promise for a user, we'll then get a user, and then we'll end up getting messages with the user's message IDs, and then we'll end up getting, comment IDs from this first message, and then we can display the first comment, or if there's an error, we can end up doing something else. But the whole idea here is something that we've seen before, where if you don't have promises, you end up basically having this nested callback because, again, the whole idea is we want to do one thing before the other. And promises allow us to get away from nesting and do things in a linear way. So what's a promise? Right? A promise represents the eventual result of an asynchronous operation. We don't say whether or not the result is successful or a failure. It could be either one. But at some point, it should end up resolving itself or rejecting itself so we can end up working with that result. So this is some sort of wizard. I don't really know what this is, but it's not my thing, guys. Not my thing.
Really?
No clue. Gandalf. So, the most important thing is that, internally, when we end up thinking about a promise, this is really what you're going to be, building is under the hood. Right? When we work with promises, all we really care about are two things, right? Up to this point. Then and catch. That's it. That's all really we care about. But internally, how it ends up storing this information. So within a promise itself, a promise might not be rejected or resolved. Okay? We could call it fulfilled or rejected, in which case it's in a pending state. So a promise can be in one of three states. Either it's pending, which means it hasn't been fulfilled or rejected, and also some information. So a value, if in fact it's been fulfilled, and a reason, if in fact it's been rejected. So this is internally what's going on. So if we end up looking at promise one, and its state is pending, it's not going to have any data, but if it ends up getting fulfilled, its state is going to be fulfilled and it's going to have some data. And again, the promises only change state when they're pending. Okay? So once a promise is resolved or rejected, there's nothing you could do with it. It's been rejected with some reason. It's been resolved or fulfilled with some value. And this is why you can end up taking a promise and then giving it a success handler and a failure handler. So what this slide is showing is that if we end up adding a handler to a promise and the promise ends up settling, that handler will be called once. So for instance, we end up saying, user.create, we put a handler in it, okay? When we end up going and the user ends up getting created, assuming it gets created, that handler ends up getting called. Handler's not going to get called a second time. Handler's only going to get called once. But one of the things that's interesting is that a promise could already have been settled. Okay? We actually saw this when we ended up doing that connect, because we said, hey, look, the promise exists, return me the promise, and we could call then on it again at that point. So the promise could already have been settled, and then we can end up adding a handler to it, and that handler could be called as well. So again, this is really what makes promises portable. Doesn't matter if the promise was has already been resolved. You could still take that promise that's already been resolved, put a then on it, and your handler will end up getting called. You could take that promise that's been resolved again, you put a catch on it. It's never going to end up getting called because, again, that promise has already been fulfilled. That promise has already been resolved. Okay?
Can you say just a few words about what that in the abstract allows you to do? So a promise represents the process of one thread.
Let me try to see if I could come up with an example. I could show you here. Hold on, there was a slide where
Dependency between threads? Is that what
absolutely nothing to do with threads. There's no threading involved with this. If there's threading that's happening under the covers, it's totally meaningless for what we're doing. Let me try to see if I can find. I thought there was one slide here that showed us how to do this. So here's an example. Okay, we have a user promise somewhere that gets us a user, and when this ends up getting, and we could call then on it for welcome user. Now let's say that when we have this user promise. Okay, let's say the user promise is taking a while to make a connection to a database. Okay? So what will end up happening is that this will eventually end up getting called. Okay? That promise ends up resolving. If I put this code in a set timeout block and call this 10 seconds after this thing ends up getting called, okay, this will still get called. Okay? It's just a resolved promise. It'll get called very quickly because it's a resolved promise, but it'll end up getting called. And if 20 seconds from now I took that same promise, okay, that'll end up getting resolved as well. The point is you don't have to worry about when it got resolved. You want the information on the user.
Why would you want to add a handler to the promise after it's settled? Is that only because
You don't know when it gets settled. How do you know when it's going to get settled?
I mean, theoretically, if you're in serial adding thens.
Who says you're in serial?
So you could
Yeah.
you could just make a promise that immediately returns a string. So by the time you've added an then, it immediately has settled. So that's like a situation you would want to do that in.
Maybe there's many places in my application where I want to have this user, and that user is a call that's being made to a database, and I don't want to call the database every time. So I do this user promise. I pass it around in my application. If it's been resolved already, great. I've got the user. It's pretty quick. It doesn't hit the database again. If it's the first time that someone ended up using it, it's going to end up hitting the database. So it makes the promise portable. Okay? I want to have that promise for a user. I mean, the thing is that what are your other alternatives?
Well, the alternatives are to add handlers
Before?
created the promise. Yeah.
Okay. Well, that's putting a bit of a constraint on you, isn't it?
It's what I'm not getting is the certain what those constraints practically disallow me from doing that I want to do.
Different routes in your Express application. So you have this promise to go and get a user. Okay? When your Express application ends up loading, you have different routes that get called. Okay? And you want to basically use that user's information. So maybe someone will never end up hitting those routes that ask for the user, but the first one that does, right, that'll end up getting resolved, and you could keep on, and you could call that promise in other routes. I mean, we used it practically when we were connecting to our database. I mean, that was kind of an obvious one. If we had a promise for our database, we might want to use that connection in multiple places. If that connection was resolved, great. Give me that resolved promise. If it didn't, I'll wait for the connection.
The handler is the then, or am I missing?
The handler, no. Let's be really careful. Okay, let's be very, very careful. The promise has a then method.
Yes.
Okay, the handler is inside the then.
And the handler, all right, so you ask to do, so you ask to get a user in this example.
Mm-hmm.
You get it. It now knows that it can go to the then because that's resolved, so that's a good thing. It goes into the then, and what is it? Tell me what a handler is now. Now you're making a decision as to what you're doing with.
Could be anything. I mean, the bottom line is that you want this promise for a user. Okay? Maybe in my application loads, I want to get want some promise for the 50 last items that got put in my database. Okay? Maybe I want to do it then because I want to delete those results. Okay? Maybe I want to do it then because I want to log those results. Okay? The portable promise gives me the ability, without this portable promise, I'd have to take the results from that first, if I was doing it with a callback, I would have to take the results from that callback and stick them up in some global variable somewhere that I could end up accessing later on. Here, I don't care when these things settle. Okay? All I know is eventually I'm going to get the result of the user promise, which is going to give me a user. When will I get it? When it's done. Okay? That's the whole nature of a promise. Okay? The fact that it's portable is a big plus.
That's a problem with the handler, not the promise taking forever to come back to us.
Say it one more time.
A promise is pending until it resolves to either a result or an error,
Right.
right?
In which case, any existing handlers that are attached to it, okay, success handlers will end up getting called that are currently attached to it. But in the future, if anyone has access to that promise, okay, and they want to attach to it, and it's been resolved, they can still attach to it.
Is
It's
there
totally
an example
portable.
of this later?
I'm doing one right now.
Good.
This is it.
I mean, this is it?
Yeah.
I'm still having a problem with handler, so you know what, leave me behind. Maybe I'll figure it out.
Okay. So what does this end up solving, right? Again, we've seen this, so this is not something that you haven't seen. You've seen code that ends up looking like this. We've seen it. We've seen it. We get error messages. What do we do when we have error messages? Okay. This nested callback hell is solved by promises. Okay. And the reason why this ends up working is that if a then ends up returning another promise, you could end up chaining it. Okay. So again, the promise library is written in a way that when it ends up getting returned inside of this then, if this ends up returning another promise, the next then won't end up getting called until this promise ends up resolving. This is the whole magic of promises, and it's going to be less magical when you end up writing the library. But in this case, I want to get a user, right? And then I'm going to take the user's messages to get the messages. I'm going to take the first message, okay? I've got the comment IDs, and then I'm going to display the first comment, right? Again, assuming that there's no way to get this stuff all at one time, I'm able to go down this chain in a linear way without worrying about callbacks, and I could put a catch right at the end to deal with an error. So, you know, we've seen this before, and I've mentioned this a number of times. This is totally meaningless, okay? Putting and Ilya, we spoke a little bit about this too, that when you have a callback, the fact is returning something from a callback is a black hole. It's nothing. It's not going anywhere. There's nothing to get it. Okay? So, you know, this gives us absolutely nothing. This is not going to work if we use this in code because, again, this could very well be undefined when we end up doing this because who knows, in fact, if person has been populated at the point that it's being used. Now, ideally, if we sort of think about kind of a fantasy solution, right, we could make the case of, hey, look, here's container A, and we're going to call this, you know, async data, and we'll get some data, and we're going to tell container A to save itself, okay, which is going to be another asynchronous operation. And then outside of here, we could say to container A, hey, look, do me a favor. When you're saved, okay, I want to do something else. And that's really, in fact, what a promise is. Everyone knows who this is. No idea. Anyway, huh?
Hagrid from Harry Potter.
You know, my son dressed up as him one year for Halloween. I should know that. So, you know, there's different standards for promises, and there are different libraries that end up implementing them. So, we've used some libraries that deal with promises on their own. We use the Sequelize library. We'll end up looking at Axios and the Fetch library, which work with promises. We've actually got promise constructors that we could end up creating. We did this with the Bluebird library. And there's also ways that we can end up taking libraries that are asynchronous and turning them into promise libraries. Again, it's just a question of sort of wrapping around these asynchronous calls and creating a promise and resolving and rejecting a promise. And we've done that. When we had code that was asynchronous, we returned the promise and we decided to resolve and reject the promise at some point in the future. So how do we end up making new promises? Well, you know, one of the things we could do, this would be a way of, you know, doing a read file which has a callback function, and turning it into a promise. So in this case, we've got a promise for this file. We're using a promise constructor. We've seen this before in the Bluebird library. Promise constructor. I shouldn't even say the Bluebird library. This is actually in ES6 as well. You basically create a new promise, okay? And you give it a callback function. This callback function will end up getting called immediately with a resolve and a reject object. And internally within here, you do whatever you want to do, and it's up to you at some point to end up calling resolve and reject. If you don't call resolve or reject, then these handlers will never end up getting called. So this is a way of permissifying an existing function, right? Here's kind of a silly thing you could do, but you could create a promise here by just specifying right off the bat. So promise for 1, 2, 3 is really going to be result in a resolved promise. So on this line, if we ended up saying promise for 1, 2, 3 dot then, and we ended up putting a function in here, we would end up having a resolved promise. If we ended up doing this, we would have a rejected promise, and we could find it by either putting a then in with 2 handlers or putting a catch in. There's a number of ways that you could deal with nodes. So for instance, one of the things you could end up doing is that there's some sort of magic with Bluebird, and you could say to Bluebird, hey, look, Bluebird, do me a favor, permissify all the FS functions. And Bluebird will actually go and add to the FS object. It'll actually create new methods. And again, you could do this manually. We did it manually. You did it in the workshop. But what this will end up doing is that your read file object will now result in another method called read file asynchronously, which will be a promise, in which case you don't have to put the callback function in, but you can end up basically permissifying. So this is something that's sometimes done when you want to take a lot of code that's asynchronous and you hate it and you want to permissify it. So let's talk a little bit about doing a then on the same promise. Let's say you have this promise and you're setting up your, right? So these would be examples, right? Vince, you were asking before. These are examples of callback handlers. Same promise, okay? Promise 1, again, promises are portable. Yawning? This is so exciting. So promise 1 is basically we're going to have a success handler with FA is a success handler, FB is a success handler, and FC is a success handler. And let's just say right now, it's in the pending state. When the promise ends up getting fulfilled with a value, FA will end up getting called. With 5, FB will end up getting called, and FC will end up getting called, right? That's not chaining. That's basically a result of the fact that promises are portable, and you could take the same promise and call a then on it 500 times, and when it's resolved, okay, whatever was in that then block, okay, those 500 then blocks will end up getting called. So you could also, after the fact, decide that you're going to do an FD, that promise has already been resolved, and after the fact, you want to then call it, and right off the bat, it's a resolved promise, and this will end up getting called. So the magic is also that a then ends up returning a new promise. So in fact, you could take this promise for something, you then get another promise that you could end up calling, you then get another promise that you could end up calling, and again, the reason why it ends up working is that the then method returns a new promise. So it makes sense, if a then method call returns a new promise, then it makes sense that you can call then on it. If this ends up returning a new promise, it makes sense that you could call then on it. If this ends up returning a new promise, it makes sense that you can call catch on it as well. Huh? If it gets rejected, right, at any stage of the game. So within a handler, if you end up returning thing B, okay, what is promise? So a promise, if you end up returning thing B, what will end up happening is that if thing B is in fact a promise, okay, then you could end up chaining a then here, but this won't end up getting called until that promise ends up getting resolved. But in fact, if thing B is just a number, okay, or it's nothing happening, it's not a promise, again, it'll just end up getting passed through. And we've seen that a bunch of times in the code that we've written so far for promises. Okay, so this is a big slide that is showing what the promise chain looks like. Again, a promise is either going to be handled with a value or rejected for a reason, right? And then, in fact, this handler can end up returning another promise as well. Now, I think what is a little bit more helpful is just sort of thinking about what this promise chain ends up looking like. So you're right about this. If you don't end up putting, I didn't actually know this, if you don't end up putting any sort of function within the promise chain, now again, I'm not sure why you would do this, but you can do this. What ends up happening, the bottom line with this is that promises are going to look for the first safe place to land. So if you have this promise 0 and it ends up getting resolved with hello, it's going to look to land somewhere in a handler. Okay? There's no handler in P1, P2, P3, P4, P5. Eventually it goes down here to P6. Okay? And what will end up happening is that it'll end up logging out to the console. It's going to look for a safe place to land. Okay? So the fulfillment is bundled down to the first available. I always say it's looking for a soft spot to land, and the console will end up logging out hello.
That's what I said before. That's what you were talking about?
Yes. Again, you could do it, but if I looked at your code and saw that you put in a bunch of thens with nothing in them, I would think it'd be a little bit strange, right? Doesn't really make any sense. So if we look at this other example, okay, and this other example says, hey, look, the promise ends up fulfilling with hello. Again, we've got this scenario in which case the exact same thing is going to happen. It's going to look for a successful spot to land. It's not going to find it at P1, at P2, at P3, at P4, at P5. It's going to find it all the way at the bottom, and this is what it's going to end up logging. So if we end up looking at another example here, and we have a promise 0 that is rejected, right, it too is going to look for a soft spot to land. Either it's going to look for a catch, okay, or it's going to look for a then that has a second parameter. Again, if it does nothing, then obviously nothing is going to happen. But assuming that the promise is going to be resolved or rejected, in our case, if it ends up getting rejected, right, this is going to end up hitting this bound log, which I guess is just going to print out sorry. As opposed to if we go up here, okay, and if this ends up getting rejected, and I think we're not showing the bound log function, I think we had it on the other side, but in this case, if the promise 0 ends up getting rejected, again, it's looking for a soft spot. None here, right? That's a success handler. None here, there's nothing. None here, no functions here. Comes down to here. It ends up calling this, and what's going to happen is that you're going to get console log sorry with an exclamation point.
That fourth then is, because it has 2 parameters.
It's the equivalent of a catch.
Excuse me?
It's the equivalent of a catch.
That's what I was about to say.
Mhm.
The first one is the positive result. It was actually a result. And the second one is the error. When you started talking about handlers before, I was thinking that last one will have a handler inside to handle the response and error, right? Whereas the other ones are just the next activity. I mean, I realize it's got to result in a promise, but it's a next activity that's going to create a result, right? I mean, that last then is very different than the first three. Because it's got a handler in it, or am I completely...
No, the first one has a handler in it. Bound log is a handler. Let's assume it's a function. It's a handler, but it's a success handler.
Oh, right.
Right? So yeah, that has a handler in as well. The other ones don't. That's correct. Yeah, I mean, because look, in essence, you know, if the promise is the eventual result of something, okay, you want to handle that result. Whether that result is something that's successful or rejected. Again, internally, the promise has 3 states. States are going to be that it's pending, in which case no handlers end up getting called. It's got a resolved state, in which case it gets resolved with a value. It's got a rejected state, in which case it gets rejected with a message. So here, you know, this is just another example where we have promise A, if it ends up getting fulfilled with hello. So here's something to throw you off by putting in a third function. And here, you know, this is just going to console log hello. Promise A is rejected. Again, after the 2 functions, there's nothing that ends up happening. I guess maybe there would be some way of doing something with that third handler, but there isn't. So, you know, this my function too is not accomplishing anything. Again, the way that I would sort of think about it is, you know, it's going to be looking for this soft spot to land.
Would it have landed in my function 1?
When?
The promise A thing, coming back with hello.
Is fulfilled with hello. Yeah, it would. It'll land in my function 1. That's correct. And then what happens after that?
I don't know. It doesn't say what my function 1 does.
No, my function 1 would be a rejection handler,
Oh, so that, I'm sorry.
right?
I realized that. So that was a success, a response. It's looking for a handler because it was a response, a result, excuse me. It's looking for a handler in the first parameter because that's what is needed.
Right. It's been a promise has been fulfilled or resolved. I guess we could use those interchangeably. So it's going to look for a success handler.
Right, which is the first parameter.
Right.
I get it.
So another thing that you could end up doing, I mean, what you end up getting from a then, if you end up getting a result from a promise, so you get this return value. So, you know, if we use the promise for value 1, we end up getting another promise for value 2. We could do that on the top, but probably a better way to do it is to basically say, hey, look, we've got this successful callback for value 1. If we want to end up moving it down the chain, right, just put a return here. And this way, we can end up going down the chain in a linear way. I mean, the thing that's happening here, you could look at val2 and say to yourself, well, you know, what if val2 is not a promise? But what will end up happening is that in terms of a promise chain, what will end up happening is that this will just be considered a resolved promise that will end up going down to here. Okay? The only way that things don't end up going down the chain is if what happens? Or we have a promise that's never resolved. Right? What if you don't put anything in the return? What do you think bubbles down? You don't put anything in. Huh? That won't hang. Won't hang. It's not a promise if you don't put anything in there. You don't return anything. What does JavaScript usually do if you don't do anything? What value do you get? Undefined. Undefined will get passed down.
I've seen it work. If there's only one line and you're not returning, and that one line creates a promise, and that promise gets passed to the next end block. Is that
Yeah.
right? It's just the words in text.
You mean where you do the fat arrows and you're not returning anything? Yeah, the fat arrows, internally the fat arrows end up returning that promise. But that's a result of the fat arrows, not the promise library. That's the equivalent of putting a return in there. But if you don't return anything in there, that's fine. Just means undefined will go down to you'll be basically resolving with the value undefined. So, on the same, token here, right, we could end up, going down this promise chain. Again, I think what ends up happening here is that, this, for me at least, this becomes much more readable, right? Promise for a user, you get the user, promise for messages, as opposed to, putting this here. By the way, you could take this promise and put a then underneath here. You'll get to the same result, but it doesn't make any sense. Okay? It makes more sense if, in fact, you're going here and you're getting the promise for messages and you end up going through the promise chain. Again, if you wanted to make this promise for messages portable and pass it somewhere else, you could, but again, let's assume we're not doing that. So again, the main thing here is that you're getting fulfilled with a value, you're getting rejected for a reason, right? And you have this handler which ends up returning another promise. The other thing that happens here is that if you end up having an exception within a then, right? If you have any sort of exception within a then block, okay, that's basically a rejection. It's an error. So if you end up throwing from a then block, what will end up happening is that that's considered a rejected promise. Okay? An error is considered a rejected promise. So if there's a throw from within this then block, okay, then it's going to look for a safe place to land. It's a rejected promise, and it's going to end up finding it right here. That's why, if you put that catch at the end, anywhere that there's either a rejection, okay, or if you had some code that was actually running synchronously, which could happen, and something ends up getting thrown, right, you'll end up going down to the next era. So, one of the things that we've actually been sort of warned about this a little bit. You've actually seen this when we didn't end up handling our errors when we were something was getting thrown inside of it. Then we would see an issue where, hey, look, you have this promise that you're not dealing with, and that error goes away when we end up putting our catch in. So again, libraries at this point are going to give us warning for that. So looking at some examples of how this might end up working. So there's libraries that this is a little bit outdated. This is actually from Angular. But what we could end up doing here is that we could take these API calls and we could map them. And what we're doing is we're actually getting a collection of promises. And we've seen this where we could use the all, and we could say, hey, look, promise.all. Here are a bunch of these promises that are getting called. And again, one request might be faster than the other request, but the bottom line is that what you're doing is that you're going to basically say, hey, look, when all these promises end up getting resolved, in which case you're going to end up printing out the results of your data. So again, this is just a question of now taking individual promises and aggregating them together in an all. And we've done that before, right? We've creating a product and a category and saying, we don't really care what the order is, which is faster than the other one. But when both those things are done, we want to do something with this product and this category, or we did several products and several categories. So there is, promises are built in to Node. We could also use Bluebird for promises, and we've seen promises quite a bit. We could have this idea of, a promise with Sequelize, where we could do a find, we could do a create, we could do a save. You've seen a destroy as well. We could even write an actual query with Sequelize. All these things are promises. We've done syncs as well. So there's going to be some reading in here that will end up saving, having as well. But the main thing here is that we're going to end up creating a promise library. Let's save this.